Hi friends, welcome back to our YouTube channel. Today we have to discuss about program control instructions in computer architecture course, computer organization course, computer organization and architecture course. Before going to program control instruction, what is sequential instruction execution? What is the need for going into program control instructions? That can be explained with this example program. Suppose we are taking a program. That program contains two parts. One is main program and another one is subprogram or a called function or a subroutine. The main program contains 176 instructions that are stored in 176 addresses, and the subprogram contains 4 instructions. Their addresses are here: 300, 301, 302, 303. Now, how sequential instruction execution can be done? First, initially we are taking one register, that register called as PC. PC stands for program counter. It can monitor all the instructions in the program. PC initially contains the address of the first instruction. Okay, PC always points to the address of the first instruction. So, first instruction address is 100. Now, PC contains the 100 instruction that is to be read from the memory. Once this instruction is performing its execution, now the PC points to the next instruction that is to be executed. When we are executing instruction 1 at the address 100, while executing this instruction, PC contains the address of the next instruction to be executed. What is the next instruction address? That is instruction 2. Its address is 101. Now, while executing instruction 2, then PC contains the address of the next instruction that is to be executed. Next instruction is instruction 3. Instruction 3 contains the address 102. Now it contains 102. Okay. In this way, PC always contains the address of the next instruction to be executed while the current instruction to be executed. Okay. So in this way, we are executing all the instructions of a program. So instruction 1 is successfully executed, then we can go for instruction 2. Instruction 2 is successfully executed, then we can go for instruction 3. Instruction 3 is successfully executed, then we can go for instruction 4. Instruction 4 is successfully executed, then we can go for instruction 5. In this way, 175 instruction is now executing, then it is successfully completed, then we can go for 176 instructions. In this way, 176 instructions in the main program is successfully completed their execution. Okay, that is called as sequential execution. Okay, is there any possibility to change the sequential execution? Yes, there is a possibility is there for changing the sequential instruction execution. So by using program control instructions, we are changing the sequential instruction execution by using some instructions. That instructions are called as program control instructions. Now suppose I am taking one example. Okay, suppose now I am executing 102 instruction 3 at address 102. Okay, while executing this instruction, so PC points to the address of the next instruction to be executed. So then PC contains 103. Now we are executing this instruction at address 103. In that address, here branch or jump instruction, we are transferring the program control from this instruction to 175. 175 means this one. Okay, so the program control can be transferred from this line to this line, this line to this line. Okay, what is the meaning of this one? While executing the instruction at address 103, the instruction is branch or jump 175. That means we are transferring the program control from this current instruction at address 103 to 175 address. So this is 175. The program control can be transferred from 103 to 175. Okay, that means we are changing the sequential instruction execution by using this instruction. Here, without using any condition, we are transferring the program control from 103 address to 175. Okay, now while executing this instruction, so PC contains the address of the next instruction to be executed. Generally, while executing 103 instruction at 103 address, then PC contains 104 generally. But here in this case, we are executing instruction at address 103. The program control can be transferred from 103 address to 175. 175 instead of 104. So PC contains 175. So then PC contains 175 instead of 104. So this is nothing but we are transferring the program control from one location to another location by using some instructions. That instructions are called as program control instructions. Okay, we are transferring the program control from one location to another location in the program. So because of that reason, sequential execution can be altered. Sequential execution can be altered. Generally, after executing 103, in the sequential instruction execution, we are executing 104. But whatever the instruction that is present in 103, because of that instruction, we are transferring the program control from 103 to 175. Okay. So because of this instruction, we are transferring the program control from this location to this location. That instruction is called as program control instruction. Next, another example. Suppose this is a called function is add function. Okay. Next, here I am calling function in the main program. Okay. Now we are executing 103 instruction. 103 instruction that is there at address 103. In 103, what is the instruction is there? We are calling one function that is called as calling function. Then the program control can be transferred from calling function to called function. Calling function to called function. That means because of this instruction, we are transferring the program control from 103 line to 103 address to 300 address. Okay. While executing this instruction at address 103, so PC contains the address of the next instruction to be executed. Next instruction address is 300. Okay. Instead of 104, PC contains only 300. Because of this instruction, we are transferring the program control from 103 address to 300. Okay. So this instruction is called as program control instruction. Okay, here what instruction we have to use? Call instruction. Okay, because of that call instruction, we are transferring the program control from calling function to called function. Here calling function name is add function. By executing this function, we are transferring the program control from calling function to called function, that is 103 address to 300 address. For that purpose, we have to use one instruction. That instruction is called as call instruction. So that type of instruction is called as program control instruction. Okay, so simply we can say that because of that program control instructions, we are transferring the program control from one location to another location in the program. For that purpose, we have to use instructions called as program control instructions. Okay. A program control instruction is a instruction when we are executing these instructions may change the address value in the program counter. Because of that reason, it can causes the flow of control to be altered. So that means because of updating the address value in the program counter, it can causes the flow of program control to be altered. Okay, so while executing 103 instruction, the program counter contains 104. Instead of 104, we are updating the program counter value with 300 address. Because of that reason, 103 instruction is executed, then the program control can be transferred from 103 to 300. Okay, only by updating the address value in the program counter. Okay, because of that reason, it causes the flow of control to be altered. By updating the address value in the program counter, so it may causes the break in the sequence of instruction execution. So that means sequential instruction execution can have a break because of that instructions. That instructions are called as program control instructions. Okay, so while executing program control instructions, we are updating the address value in the program counter. Because of that reason, it causes a break in the flow of program execution. Because of that reason, it may causes a break in the sequence of instruction execution. Okay. So simply we can say that program control instructions are used for controlling the flow of program execution from one location to another location in the program. By updating the address value in the program counter, because of that reason, it causes a break in the sequence of instruction execution. It may causes a flow of control to be altered. Okay. Now, so these are the list of typical program control instructions that are available in this course. The first column represents the name of the program control instruction, and the second column represents the mnemonic. That means what is the symbol we have to use for representing that program control instruction. So here first instruction is branch instruction. The symbol that we have to use for representing the branch instruction is BR. Second instruction is a jump. The symbol we have to represent the jump instruction is JMP. Next instruction is skip instruction. The symbol we have to use for representing skip instruction is SKP. Next instruction is call instruction. The symbol we have to use for representing the call instruction is CALL. Next one, return instruction. The symbol we have to represent for representing the return instruction is RET. Next, compare instruction. The compare instruction representation is CMP. Next one, test instruction. The symbol we have to use for representing the test instruction is TST. Okay, so these are the 7 program control instructions, and its name of that instruction and what is the symbol we have to use for representing that instruction, that is listed in table 1. Okay, now first one is branch instruction. Okay, first one is branch instruction. Branch instruction can be represented by using the mnemonic, that is BR. So branch instruction is a one address instruction. That means it can use only one address field. Okay, so that is the assembly language representation for branch instruction is BR ADD. ADD is nothing but the symbol we have to use for representing the address. Okay, so BR is nothing but branch instruction symbol, and ADD is the symbol we have to use for representing the address. Okay, for example, BR 400. BR 400. That means we are changing the program control from the current instruction to 400 instruction in the program. Okay, next one, another example, BR 175. We are changing the program control from the current instruction to 175 address. 175 address. Whatever the instruction that is present at the address 175, program control can be transferred from the current instruction address to instruction that is present at 175 address. Okay, so branch instruction contains two types. One is unconditional branch. Unconditional branch. And the second one is conditional branch. What is unconditional branch and what is conditional branch? Unconditional branch means without any condition we are transferring the program control from the current address to whatever the address that is present in the branch instruction. Without any condition we are transferring the program control from one location to another location. Okay, that type of branch is called as unconditional branch. So the example for unconditional branch is BR 175. That means without any condition we are transferring the program control from the current instruction, from the currently executing instruction to the instruction that is present at 175 address. Okay, we are not using any condition for transferring the program control from one location to another location. That type of branch is called as unconditional branch. Okay, next one is conditional branch. By using some condition, we are transferring the program control from one location to another location. So that type of branch is called as conditional branch. First, we have to evaluate the condition. If the condition is met, then the program control can be transferred from one location to another location. That type of branch is called as conditional branch. Okay. Now, suppose at 103 address, we are taking one instruction, that is a branch instruction. So whenever this instruction at 103 address is BR 175. So without any condition, we are transferring the program control from address 103 to 175. So the program control can be transferred from instruction that is present at 103 to instruction that is present at 175 address. We are not mentioning any condition. Okay, so that type of branch is called as unconditional branch. Suppose here we are writing one condition. Okay, first we have to evaluate this condition at 103 address. If after evaluating that condition, if it is true, then the program control can be transferred from 103 to 175. If the condition is false, then the program control can be proceeded to 103 to 104 instruction, because if the condition is not satisfied, then the program control proceed with the next instruction, that is 104. So this type of branches are available in the program control instruction. One is unconditional, second one is conditional. Okay, so this is the example for branch instruction. Okay, next one, jump instruction. Jump instruction is also similar to the functionality of branch instruction. Simply we have to use another mnemonic, but the functionality of jump instruction is similar to branch instruction. Some books follow branch instruction and some textbooks follow jump instruction. Mnemonic is different. That means the symbol we have to use for representing branch and jump instruction is different, but functionality is same. Okay. Next one is skip instruction. So skip instruction is used for skip the next instruction while executing the current instruction. So skip instruction does not contain any address field. So hence we can say that skip instruction is zero address instruction. So for example, here I am writing SKP. Here I am writing SKP. Okay, that means now we are executing 103 instruction. Then the program counter now contains 103. While executing the instruction that is present at 103, then the program counter contains what is the next instruction to be executed. While executing the skip instruction at 103 address, then the program counter contains only 105 address, because by executing the skip instruction that is present at 103 address, we are skip the next instruction. That means the instruction that is present at 104 address simply we have to skip. Then the program counter can pointing to 105. So after executing 103 instruction, so then the program counter contains 105 instruction by skipping the instruction that is present in the 104. So skip instruction is used for skip the next instruction while executing the current instruction. For that purpose, we have to use skip instruction. Skip the next instruction while executing the current instruction. Now I am executing 103 instruction. The instruction that is present at 104 is skipped because I am executing escape instruction at 103 address. Because of that reason, the instruction at 104 is skipped. Then the program counter contains 105. After executing 103 instruction, executing 105 instruction. After that, 106, 107, 108 up to 176 instructions are executed. So skip instruction is used for skipping the next instruction. Next one. Next instruction is call instruction. Okay. So here call instruction. Suppose I am executing call instruction at 103 address. Okay. That means at 103 address we are calling one function. That function is called as add function. That function is called as add function. Then what is the next instruction that is to be executed after instruction at 103 address? The program counter, the program control can be transferred from this instruction to this instruction. This is called function is available at 300 address. Okay, while executing 103 instruction, what is the next instruction to be executed? That is 300. Now PC contains 300. After executing 103 instruction, then the program control can immediately transfer from 103 to 300. Okay, so the program control can be transferred from calling function to called function by using call instruction. Next one. Once the instructions in the called function are executed, then the program control can be transferred from called function to which place? Okay, so here I am writing RET instruction, RET 104. RET 104. So that is RET is nothing but return instruction. Okay, while transferring the program control from 103 to 300, once all the instructions in the called function are executed, then the program control can be returned to which address? So that is present at the last instruction in the called function RET 304. The program control can be transferred from 303 to 104. For that purpose, we have to use return instruction. So return instruction is used for transferring the program control from called function to main program. Called function to main program. Okay. Once the program control can be transferred from 103 to 300, once all the instructions in the called function are executed, now the program control can be transferred from called function to which address? That is mentioned here return 104. The program control can be transferred from 303 address to 104 address. That is, so while executing the 303 instruction in the program counter, while executing this instruction, the program counter contains what is the next instruction to be executed. After executing 303, we can go for 104. Okay. For that purpose, we have to use a return instruction. Okay. So these two instructions are used for executing the subroutine. Subroutine is nothing but function. Okay. Here, this instruction is used for transferring the program control from calling function to called function. This instruction is used for transferring the program control from called function to calling function in the main program. Okay, for that purpose, we have to use call instruction and return instruction. Okay, next one, compare instruction. What is the use of compare instruction? Suppose I am taking two operands. A contains 1011 and B contains 0011. Okay. So operand A contains 1011, operand B contains 0011. How to compare these two operands? These two operands are compared by using compare instruction. When we are executing the compare instruction, simply we have to perform the subtraction operation. So compare instruction can be performed by using subtraction operation. Whatever the result we are getting, that result is not stored. By using that result, we can evaluate some flags. That flags are zero flag, sign flag, overflow flag. So these are the some flags. Okay. By using that flags, we are evaluating the conditions. Once the condition is met, we are transferring the program control from one location to another location. Okay. For that purpose, we have to use compare instruction. Compare instruction is used for comparing the two operands by performing the subtraction operation. Once we are performing the subtraction operation by using ALU, the result is not stored, but the result is evaluated based on some flag bits. Okay. So based on the flag bit values, we have to transfer the program control from one location to another location in the program. Next one, test instruction. So test instruction is used for performing the ANDing operation between two operands. So here A is one operand that contains the value 1011. B contains the operand that value is 0011. Now we are performing the AND operation. So A and B operation. After performing the AND operation, 1 into 1 is nothing but 1. 1 into 1 is nothing but 1. 0 into 0, that is nothing but 0. 1 and 0, that is nothing but 0. This is the result. This result is not stored. Okay. But based on the result, we have to evaluate some flag bits. So based on that flag bits, we have to transfer the program control from one location to another location in the program. Okay, so these 7 instructions are called as program control instruction. Okay, here the first one is branch instruction. We are transferring the program control from one location to another location by using branch instruction. So branch instruction can be represented by using the symbol BR. It can contain only one address field. Okay, whatever the address that is present in the address field, the program control immediately transferred from the current address to whatever the address value that is present in the address field of the branch instruction. So there are two types of branches. One is the conditional branch, second one is unconditional branch. In unconditional branch, we are transferring the program control without any condition. In the conditional branch, we are transferring the program control by using some conditions. Based on the condition, we are transferring the program control. If the condition is met, the program control can be transferred from one location to another location. If the condition is not met, the program control can proceed with the next instruction. Okay, so branch and jump instruction contains the similar functionality, but the mnemonics are different. Some books follow branch and some books follow jump. Skip instruction is used for skipping the next instruction while executing the current instruction. It does not use address field. It is a zero address instruction. Next, call and return instructions are used for transferring the program control from calling function to called function. Then transferring the program control from the called function to calling function, we have to return instruction. These two instructions are used for executing a function or a subroutine. And compare instruction is used for comparing the two operands by performing the subtraction operation. Once the result is evaluated, that result is not stored. Based on that result, we have to evaluate some flag bits. Based on that flag bits, we are transferring the program control from one location to another location in the program. Next one, test instruction. Simply test instruction is used by performing ANDing operation between the two operands. After performing the ANDing operation, the result is not stored. We have to evaluate some status flags. Okay. By using that status flags, we are transferring the program control from one location to another location. So another flag is carry flag. So zero flag, sign flag, overflow flag, carry flag. Okay, after performing any ALU operation, these bits are evaluated. Based on that bit value, we are transferring the program control from one location to another location in the program. In the next video, we have to discuss about these flags, that is called as status flags. I hope all of you understanding this video. If you really understanding this video, please click on the like button and share this video to your friends and classmates. If you really like this video, please subscribe my YouTube channel. So Divvela Srinivasarao. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. For better understanding of this course, go to the channel, go to the playlist called Computer Organization or Computer Architecture. Thank you one and all for watching this video.